Hey, welcome. So today we're diving into a really strange paradox at the heart of our digital world. We've gotten unbelievably good at storing just massive amounts of data. But in the process, we've kind of backed ourselves into a corner. We've become these amazing data hoarders, but we can't get to our own treasures fast enough. So what's going on?
This right here, this is the big question. Think about it. Our ability to cram data into a tiny physical space has jumped by a factor of 1 trillion since the early days. That's a truly mind-boggling number. But our ability to read that data back? Yeah, that's a whole other story, and it's a much, much slower one. To really get a handle on this, I think the best way is to compare two pieces of tech from totally different eras. It's like a heavyweight title fight, pitting the granddaddy of all hard drives against a tiny modern-day champion. This story really tells you everything you need to know. Okay, so in the left corner, we have the IBM Ramac 350 from 1956. This thing was the size of 2 refrigerators and held a whopping 5 megabytes of data. And in the right corner, a modern data center SSD. It fits in the palm of your hand and holds 245 times terabytes. The jump in just pure storage is it's insane. But look closely at the other numbers on this chart. That's where the real story is. But before we dig into that, let's just make sure we're on the same page with a few key terms. It's simple. Capacity is just how much you can store, the 5 megs versus 245 terabytes. Throughput is your speed. How fast can you actually read that data? And then there's latency. Latency is that frustrating little pause. It's the time you wait for the first piece of data to show up. Think of it like the time it takes to walk to the library shelf and find the right book before you can even start reading page 1. All right, so now that we've got our terms straight, we can really see where things went off the rails. Because the progress we've made in these 3 areas, it hasn't been even. Not at all. In fact, it's been wildly, almost ridiculously lopsided. Let's start with the big one, storage density. That's how much data we can cram into a physical space. That number has gone up by a factor of 1 trillion. I mean, that's a 1 followed by 12 zeros. It's a number so huge it almost doesn't feel real. And this is where you can see the problem clear as day. Look at this chart. That huge bar on the left, that's our trillion times improvement in storage. But the next bar over, our read speed, our throughput, it's only gotten 1,000,000 times better. And latency, that initial wait time, just 6,000 times better. You can literally see the enormous gap between how much we can store and how fast we can get to it. This quote from data expert Ghislaine Forney just nails it perfectly. He says, "We can increase the capacity massively, but much faster than we can read it." That's the whole problem in a nutshell. We've built this gigantic warehouse, but we're stuck with a tiny little doorway to get things out. Okay, look. Numbers like trillion and million are so big they're hard to really feel, right? So let's try an analogy. Let's imagine for a second that books and our own personal reading speed evolved at the exact same imbalanced rate as our hard drives. It would be absolutely absurd. A regular book from a couple centuries ago would have ballooned into a tome containing 650 quadrillion words. And even though our reading speed got faster, it would still take you, get this, 287 years to finish that one book. It's just an impossible task. And that's really the bottom line here. When it comes to our data, we've basically created that 287-year book. To put it bluntly, we are in big trouble. This feels like a completely hopeless situation, doesn't it? I mean, if the hardware itself has this fundamental gap, what can we possibly do? Are we just stuck? Well, no. This is where human ingenuity comes in. This is where the whole concept of big data was born. The first, and maybe the most important weapon in our arsenal, is something called parallelism. And the logic behind it is actually super simple. If one person can't read an impossibly long book, then don't have one person read it. You build a team. So here's the solution to our 287-year book problem. You don't read it alone. You take that massive book and you metaphorically shred it into 1,000,000 pieces. Then you find 1,000,000 people and you give each person just one tiny piece to read. All of a sudden, a task that would have taken centuries is done in a few hours. It's genius. And that right there is parallelization. It is the absolute core principle of big data. It's exactly what massive data centers do. Instead of trying to build one single super fast computer, they just network together thousands or even hundreds of thousands of normal, cheaper computers. Each one tackles a tiny piece of the puzzle, and together, they get it done at incredible speeds. Okay, great. So parallelization helps us fight that throughput gap.
But what about our other enemy, latency? We have all felt this one. You know, when you try to copy a folder that has thousands of little tiny files in it and the progress bar just crawls forever. Why is that so much slower than copying one single giant file? Well, the hidden culprit is latency. Every single time your computer has to start a new task, like finding and opening a file, you have to pay a small fixed time penalty. That's the latency. So with one big file, you pay that penalty once. But with 1,000 tiny files, you pay that penalty 1,000 separate times. All those little delays add up and absolutely kill your speed. So what's the solution? It's another brilliantly simple idea: batch processing. Instead of asking the system to handle 1,000 tiny individual jobs, you just group them all together into one big batch. That way, you only pay that annoying latency penalty one time, at the very beginning. Then, the system can just focus on what it's good at, moving data at full speed. And all of this whole journey, brings us to a really fascinating conclusion about a buzzword we hear all the time. It turns out big data isn't really about how big your data is. It's about the clever collection of solutions we had to invent to deal with the limitations of our own hardware. So here it is, the big takeaway. Big data is simply the toolkit we built to solve our big trouble. It's a whole set of technologies designed for the world we actually live in. It's built on parallelization to fight that slow read speed, and it uses batch processing to get around that killer latency problem. It's the engineering magic that makes that 287-year book readable. These solutions, parallelization and batching, are what make the modern internet and data science possible. They're working for now, but the amount of data we create is not slowing down. It's accelerating like crazy. So this race between our ability to store data and our ability to actually use it is far from over, which leaves us with one last question to chew on. What's the next big trouble just around the corner? What happens when even these incredible solutions aren't enough?